Okay, so this is a similar model to last time, but this time we have a seasonal model and we're also fitting trends. The equations we're using are on page 345. At the bottom of the page, equation 9.19, and the actual example is given in figure, it's example 9.15, and it's given in figure 9.21. So we have some data in car sales. We suspect it's seasonal. For example, car sales seem higher in the summer, but there also seems to be some sort of trend as car sales increase over years. So we need to kind of model car sales both with a trend and with a seasonality. Okay, so we have the data here. And again, the first year is just used to get, almost a setup to get base values for some of these things. And so the first thing we want to do is to calculate the level, which as before is the average. So it's the average of everything in the first year. Okay, and I'll just put dollars on this so we can drop down. Good. Now the trend, the initial estimate of the trend is the average change from the second year to the first year. And so this is going to be average of the second year minus the first year. And we want to kind of aggregate this out over 12 months, as this would be for an entire year, and we want a monthly trend. So we actually do it over 12 to get per month. So this would be the average increase per month. Okay, and I forgot to dollarize these things. So that's 462.48. And then as per the previous example, the seasonality is just going to be the actual value minus the level. And we don't have any sort of forecast for the first year. Okay, so now we can update. So again, this is using 9.19. And this is going to be this is going to be alpha for the level. So it's alpha times the new level, which is basically the value minus the previous seasonality. So this is exactly the same as the last example. Plus 1 minus alpha multiplied by the previous, the estimate of the for previously, which is the level at time minus 1 plus the trend. So kind of the same as last time, but this time we expect this linear trend every period, so we have to add the trend. And D4 needs to be dollarized as we're going to move it. Okay, and we didn't need to drop down that far for seasonality. Okay, and the trend is going to be beta times the new trend, which is just going to be the change in levels, plus 1 minus beta multiplied by the previous trend, which is this. And again, we're going to dollarize this. Dollarize the beta. And that should be the new trend. And then the seasonality. Again, we're now using our third smoothing concept, our third smoothing parameter, which is the gamma, multiplied by the current seasonality, updated seasonality, which is just going to be the value at time t minus the level plus kind of 1 minus F4, 1 minus gamma times our previous seasonality, which was the previous seasonality for January. And again, let's dollarize my parameters. Okay, so the next thing we want to do is we want to make a forecast. And the forecast, the forecast can't include information on this row. It has to be, which is the updated information. It has to only have previous information. So it was the previous level plus, we're going forward one period, the trend plus the previous seasonality for the month of January. And that gets us 42,272. Now, the book example does not include an error, which we might as well be consistent. So I've included an error because I want to pick optimal parameters. And here, this is just our actual value minus our forecast. Okay, that's fine. I don't know why it gave me so many decimal places. Actually, while we're here, let's just put everything on the same number of decimal places. Okay, so we should just be able to drop this down now, I say. That's looking pretty good. And the actual forecast, we could probably drop down one more. But obviously, we don't know the actual values there. And so that's our model. Okay, so let's just look for a particular month. And so we basically have alpha times our kind of updated level, which is basically our value minus the last seasonality, plus 1 minus alpha on our predicted level, which was the previous level, plus the previous trend. Then we go for the trend, and this is beta times our prediction of the trend, which is just the difference between our current level and the last level, and 1 minus beta times the previous trend. And then finally, seasonality, even simpler. It's just gamma times our current estimate of seasonality, which is just our current value minus the level, plus 1 minus gamma times the seasonality. Now, as we have like 3 years here, and some of the seasonality that we're calculating is used in the next year, hopefully we can actually utilize Solver and get some updates of these parameters. But first, let's just do it last time. And let's just do, we have our units. So we have, I'll just call this the unit sales. And we have our forecast. So let's put these into a graph. And actually, let's go all the way to January to get the next forecast in there. and control. And now let's add the forecast. And we're going to insert. Okay, so here we go. And this is going to be additive Holt winter car sales. And we're going to add chart element, period, add chart element, axis titles, vertical, and sales. Okay, so that's pretty much that, but we don't forget to do data solver. And so let's just call it the mean absolute deviation. And let's actually I call this absolute error, so I really should be the absolute error rather than the error. So I'm just gonna drop this down, Control D, and the mean of this value is just gonna be average. And so we want to minimize this by setting these parameters. So minimize by changing cells. And we're going to make them non-negative, so they're greater or equal to 0. But they also need to be less than 1. Okay, let's just see what we get. Well, you notice our average error is it's currently 2590.41. And looking at the graph, it's actually a pretty good fit, but let's just see if we can improve it. And we're 2252. Seasonality is just a complete update. Maybe the seasonality has changed a lot. We didn't improve it that much, but we have low updates of alpha and relatively low updates of beta from the initial trend. So that's our best fit model. Okay. What I will do, it's not kind of included in the examples in the book, but I will include, we have the kind of the Holt winter trend, additive Holt winter trend. I'll include 2 spreadsheets for the multiplicative trend for the car sales examples and this example, though as it's not an exercise in the book, I won't include a specific video because it's literally exactly the same, but with the multiplicative formulas rather than the additive formulas.